I just retired from Seoul National University in February and moved to a new place. Thus, am late in posting this video. The reason I opened this YouTube channel is to have an open debate with reasoning on the ideas that I've had for a long time. Thus, I posted video 1 and 3 in mathstackexchange.com asking whether there were flaws in my reasoning. Video 2 was not posted. The comments were all negative, but I was very glad because I could engage in a debate rather than brushed aside, and I'd like to thank them. This video is to present all the criticisms and my rebuttal, which allows my points more clear. The first posting was that the proof of the proposition that the limit of a converging sequence is unique is flawed. There were 3 criticisms against my reasoning. Let me repeat the riddle that I showed in video 1. For all real numbers larger than 0, a is larger than b is larger than or equal to 0. If a equals b over 2, what is b? This is a nonsense riddle because a cannot be b over 2 when a is larger than b. There is no b that satisfies b over 2 is larger than b regardless b over 2 is 0 or larger than 0. Thus, a equals b over 2 is an invalid assumption. What we want to prove is that how small epsilon may be if absolute value of x minus x prime is smaller than epsilon, then absolute value of x minus x prime is 0. You know that a stands for epsilon and b for absolute value of x minus x prime. This proof is to exclude b is larger than 0, thus proving absolute value of x minus x prime equals 0. Now, let's look at the proof. For all real number a larger than 0, a is larger than b is larger than or equal to 0. If we assume a equals b over 2 is larger than 0, this assumption of a equals b over 2 is larger than 0 leads to a contradiction that b over 2 is larger than b. Thus, b over 2 is larger than 0 is contradicted. Thus, b equals 0. Can we conclude that b equals 0 because b over 2 is larger than 0 is contradicted? No, because a equals b over 2 is an invalid assumption, as in riddle. A equals b over 2 contradicts a is larger than b regardless whether b over 2 is larger than or equal to 0. Thus, we cannot conclude b equals 0 because b over 2 is larger than 0 is contradicted. Let's see what happens if b over 2 equals 0. If we assume a equals b over 2 equals 0, this assumption of a equals b over 2 equals 0 leads to a contradiction. A equals 0 and 0 is larger than 0. Thus, we have to conclude b over 2 equals 0 is contradicted. Thus, b is larger than 0. Thus, this proof shows both b over 2 is larger than 0 and equal to 0 are contradicted. Thus, b is both 0 and larger than 0, which is nonsense. Like riddle is nonsense, this proof itself is nonsense because of an invalid assumption, A equals B over 2. There was a criticism that if B equals 0, then A equals 0, and this would not be a valid choice. When if B is larger than 0, B over 2 is a valid choice for A. Thus, the proof is correct. Let's examine the claim. The claim is that if B equals 0, then A equals 0. And this would not be a valid choice because A equals 0 is against A is larger than 0. However, the reason that A equals 0 is because we chose A equals B over 2 when we cannot choose A equals B over 2 because A equals B over 2 leads to B over 2 is larger than B by A is larger than B. Thus, we cannot choose A equals B over 2. A equals B over 2 is not a valid assumption. As the criticism claims, if B is larger than 0, is B over 2 a valid choice for A? No, it is not, because A equals B over 2 leads to B over 2 is larger than B by A is larger than B. Thus, A equals B over 2 is not a valid choice either, for B is larger than 0. A equals B over 2 is not a valid assumption. Let's compare them side by side. Criticism 1 claims that B equals 0 is not a valid choice when we choose A equals B over 2. However, A equals B over 2 is not a valid assumption in the first place because it leads to B over 2 is larger than B. Instead of concluding that the proof is nonsense, they are trying to salvage the proof by removing B equals 0 in the proof with an expression that B equals 0 would not be a valid choice. But what they are doing is covering up the nonsense which arises from an invalid assumption A equals B over 2. Rather than covering up this nonsense with B equals 0 would not be a valid choice, we should conclude that the proof itself is nonsense because of an invalid assumption A equals B over 2, which is obvious in riddle. There was a comment in the YouTube channel. For any A larger than 0 means we could replace A by B over 2. However, if it is for all A larger than 0, is it okay to replace A by B over 2? What we are trying to prove is that for A, which is epsilon, what is B, which is smaller than A? In finding B, we choose A first and then examine what is B smaller than A. Not the other way around, like taking a value B over 2 from B and then choose A from this. I will repeat. We choose small number A and then find B smaller than A. not the other way around. We do not choose A from B, which is compared, which is a logical flaw. As a side note, let's entertain this. What is B, which is larger than all real number A larger than 0? If B is larger than A, like A plus 1, for example, it leads to a paradox that B is a real number larger than all real number. Thus, we consider the concept of infinity, which is not a real number, larger than all real number. We can take B equals B to A instead of B equals A plus 1 with the same conclusion. Please take a note. We take A first and then B in this reasoning. And what is B, which is smaller than all real number A larger than 0? If we take B equals A over 2, then there is a paradox that B is a real number smaller than all real number A larger than 0. Thus, we can consider the concept of infinitesimal, which is not a real number smaller than all real number larger than 0. Again, we take A and then B. In mainstream real number analysis, there is no infinity or infinitesimal. It only approaches infinity or infinitesimal. Non-standard analysis has infinity omega and infinitesimal epsilon in the field R star. It is based on transfer principle. Thus, omega is smaller than 2 omega is smaller than 3 omega ... and epsilon is smaller than 2 epsilon is smaller than 3 epsilon ... Later, I propose an extended number system with infinity Aleph-0 and infinitesimal iota as 1 over Aleph-0 as elements. This system is strictly based on the premise of 1-to-1 correspondence. Thus, Aleph-0 equals 2 Aleph-0 equals 3 Aleph-0 ... and iota equals 2 iota equals 3 iota ... Criticism 2 was, for all real number A larger than 0, A is larger than B, B is larger than or equal to 0, then what is B? B equals 0 is good, because the only non-negative real number, which is less than every positive real number, is 0. But if you ask, will there be B that satisfies A is larger than B is larger than 0? The answer is yes. There is B that satisfies A is larger than B is larger than 0 for all real number larger than 0. Because every positive real number has a smaller positive real number. Criticism 3 was by showing a different proof. Suppose A sub n is a sequence such that A sub n approaches P sub 1 as n approaches infinity, and A sub n approaches P sub 2 as n approaches infinity. Let delta be absolute value of p sub 1 minus p sub 2. If delta is larger than 0, then let I sub 1 equal to p sub 1 plus minus delta over 2 and I sub 2 equal to p sub 2 plus minus delta over 2 as open sets containing p sub 1 and p sub 2 respectively. Since a sub n converges to p sub 1, infinitely many a sub n must lie in I sub 1. However, because intersection of I sub 1 and sub 2 is null, that means infinitely many a sub n must lie outside of I sub 2. This is a contradiction because we said a sub n converges to p sub 2. Therefore, we must conclude that delta equals 0, meaning p sub 1 equals p sub 2. The proof supposes that a sub n is a sequence such that a sub n approaches p sub 1 and p sub 2, that is, two separate numbers. It doesn't appear right because a sub n diverges into two separate numbers. What occurs during convergence is that the sequence converges to a smaller and smaller segment or range whatever in the number line. Maybe to a single number or to a very tiny segment, which includes more than one number like p sub 1 and p sub 2. Suppose a sub n converges to a very tiny segment, which includes more than one number, like p sub 1 and p sub 2. Then a sub n converges to p sub 1 and p sub 2, but not separately to p sub 1 and p sub 2. Then you cannot use the reasoning that a sub n lie in I sub 1 or I sub 2 separately. And a question arises whether a sub n converges to a very tiny segment, which includes more than one number, like p sub 1 and p sub 2, because it appears that a sub n can further converge to p sub 1 or p sub 2. That is exactly what video 3 exemplifies, that a segment in counter set is a converging sequence which has more than finitely many numbers between endpoints. There were two criticisms on video 2, which are essentially the same. That being a limit does not mean that there is a value n where it actually gets there. In fact, the whole reason we're trying to find the limit is that it never gets there for any finite n, but does get indefinitely close. Limits at infinity make no such claim. Informally, they only require that the function gets within any non-zero distance of the limit, no matter how far to the right of the real number line you are. Thus, limit x sub n approaches x and is not x. That is exactly what I am arguing for. However, based on the flawed proposition that the limit of a converging sequence is unique, Current real number analysis concludes or double-speaks that limit x of n equals x. Thus, limit 1 over n equals 0 and limit sigma 1 over 2 powered by k equals 1 and is the cause of delusion in Cauchy completeness, which will be discussed in video 8. Video 3 was an example that the limit of a converging sequence is not unique. Criticism 1 was, your logic breaks down because there are no segments in the Cantor set, so it is impossible to converge to a segment. I clearly stated in video 3, Cantor set may be said to have no segments because its length is calculated as 0 in current mathematics. A segment is just a figurative term because there are endpoints and many internal points in the segment, that is, between the endpoints. Criticism 2 was, limit sigma 1 over 2 powered by k equals 1, even when there will be infinite number of points between sigma 1 over 2 powered by k and 1. The critic takes it for granted that limit sigma 1 over 2 powered by k equals 1, which is based on limit 1 over 2 powered by k equals 0. But this is what is being questioned and examined. And Cantor set is not a set along the way, but the limit set. And there are more than finitely many numbers between the endpoints in each segment in this limit set, even though the length is calculated as 0 in current mathematics. Thus, there are more than finitely many numbers between endpoint numbers, not just along the way, but even at its limit. Criticism 3 was, video 1 is wrong, thus this example cannot be correct. What I defended video 1 in the previous part, and rather than saying this cannot be correct, they should find the flaw in the example. The following videos 4 to 8 were recorded before my retirement. Your critical comments will be appreciated. Thank you very much.